To the one over chapter 5 with my other class today. So if you don't understand anything here with me, then you can watch that recording. I mean, I'm going to teach the same thing, but since I talked for an hour, my voice is not working well now. So if you don't understand anything when I say something, let me know. Okay? Can you guys understand my voice? Is hear me? Can you guys hear me? Come on, only 3 of you are here. Just response. Thank you, Mehrab. Okay. So instead of a review today, we are going to finish chapter 5, and then in next 2 classes, we are going to do review. Kark, did you see the email I sent about final exam?
Yes, I received the email. Thank you so much, Professor.
Okay, Andy. How about Kark? Did you receive the email? The email I sent about final exam? Please check your email and respond to that email. Okay, Kark? I am not hearing anything from you. So if you are speaking, I'm not hearing you. Oh man. Yeah, so chapter 5. Oh, before I start, does anybody have any question? Any question, comments, anything? Okay, Kark. Then reply to that email. Yes or no, okay? Thank you. Okay. So chapter 5 talk about orthogonality. 2 vectors are orthogonal if their dot product or the scalar product between them is 0. Another word for orthogonal is perpendicular. So 2 vectors are perpendicular if their dot product is 0. Now, what is dot product? Dot product and scalar product, they are something. You have to find the dot product. We multiply 2 vectors element wise and then add them. So just like matrix multiplication, in matrix multiplication we have n by m matrices, and here we are multiplying only vectors. So we multiply 1 row with 1 column. Whatever result you get, that's the dot product or the scalar product, and that number is a constant. So if you have an x vector and y vector, the dot product, we represent that by x transpose y is, we multiply them element wise. So the first element in x and y plus the product of the second element in x and y plus all the elements, you add them, and then you get the result. For example, if you have vector 3, -2, 1 and 4, 3, 2, If you don't hear my voice, guys, please let me know. Okay. So if you have two vectors, 3, -2, 1, and 4, 3, 2, then their dot product is 3 times 4, 12, plus -2 times 3, which is -6, plus 1 times 2, which is 2. So when you add them, the result is 8. That's the product, the scalar product of x and y. Now, the scalar product, vectors in R2 and R3 can be represented by directed line segments. So, if you have a vector x in R2 or R3, then the length of the vector we can find by, for example, let's say you have a vector x is 1, 2. Now, if you want to find its length, Ethan, you are here finally. Thank you. So we just started chapter 5. Even though I said in my email we are going to do a review, but then I realized chapter 5 is actually a fun chapter and it's an important chapter. So I shouldn't skip that. That's why I'm starting chapter 5. So I didn't miss much. So far what I did was I said the orthogonality. Orthogonality means if you multiply two vectors, one row vector and one column vector, and the result is 0, then the two vectors you have, x and y, they're orthogonal. Orthogonal means they're perpendicular to one another. So if one vector is going this way, what's x? And the other vector is y going that way, and they're connecting with a 90-degree angle. So that product is called scalar product or dot product. Because I have to multiply the row vector with the column vector. And we did this example. We have x vector and y vector. X is 3, -2, 1, and y is 4, 3, 2. So when you multiply, one vector becomes row and the other becomes this as a column. So you do row by column multiplication. So you take each element in the row vector and multiply in the column vector. So 3 times 4, and then plus -2 times 3, and then 1 times 2. Whatever result you get, that's the dot product, the scalar product of the two vectors. And now to find the length of a vector, let's say you have a vector 1, 2. So 1, 2. 1, 2, the point is here. So to get the vector, we just connect with 0, 0, and we get the vector 1, 2. Now, if you want to know how much or how long is this 1, 2 vector, means the length of the vector, which is called the norm of the vector, we can find it by taking the square root of each element square, sum of each element square. So first element is 1, so we do 1 square. Plus our second element is 2, so we do 2 square. So we get 1 square is 1, 2 square is 4. So the length of the vector 1, 2 is square root of 5. So why do we care about that? Well, we care about that because we need to use this length into the materials we're going to learn today. So we need to know the dot product x transpose y. And you also need to know how to find the length of each vector. So dot product is simply row times column. And norm is square root of the sum of each element square. Whatever element or however element you have in your vector. Now, first thing you're going to learn is the angle between the two vectors. When you have two vectors, there are two scenarios. Could be more, but for now I can think of two scenarios. Let's say one vector is here and the other vector is here. So we have two different vectors. So where they meet, they produce an angle. So we want to know what is that angle? How much is that? Or do you have the two vectors as the same vector? Just one vector is smaller and the other vector is bigger. So if you have two vectors, obviously the angle between them is 0. So when any angle between two vectors is 0, that means two vectors are the same vector. One is a multiple of the other vector. And if your angle is not 0, that means the two vectors you have, they are two distinct vectors, two different vectors. So how do we find this angle? We find this angle using a theorem. The theorem says if x and y are two non-zero vectors in either R2 or R3, doesn't matter, and theta is the angle between them, then x transpose y means their dot product is norm of x times norm of y times cosine of that angle. So since our goal is to find the angle between them, so we need to divide both sides by square root of, sorry, not square root, norm of x and norm of y. So if you do that, then we get cosine of the angle is x transpose y divided by the product of norm of x and norm of y. But still our goal is to get this x alone. So not x, the theta alone. So we need to cancel cosine. To cancel cosine, we need to invite the cosine inverse. We apply cosine inverse to both sides. So cosine and cosine inverse cancel out, and we get the theta alone. So theta is cosine inverse of this thing, x transpose y divided by norm of x and norm of y. So you have to remember this formula. The angle between two vectors is cosine inverse of that dot product divided by the product of the length of each vector. This is one formula, but this is not the only formula. There are other formulas also. For example, you can multiply unit vectors, not multiply, yeah, you can multiply unit vectors and take the cosine inverse. So theta would be cosine inverse of the unit vectors, that product of the unit vector. So what's the unit vector? Unit vector is each vector divided by the norm of the vector. For example, if your vector is 1, 2, then we just know from before that the norm of 1, 2 is square root of 5. So you are going to divide your 1, 2 vector by square root of 5. 1, 2 vector divided by square root of 5. This looks weird because we actually don't write it this way. Instead, we do this 1 over square root of 5 times the vector. So if you do that, then we get 1 over square root of 5, 2 over square root of 5. So this is the unit vector for x, and you can do the same thing for unit vector for y. And then if you multiply these two, take the cosine inverse, you can get the angle between them. So this is another way of finding it. So whichever is easier for you, you can use that formula. Now let's do one example. So this is our first example for the final exam. This will be the final exam. Find the angle between two vectors. So you need to remember your formula. Theta is cosine inverse of x transpose y divided by norm of x times norm of y. So cosine inverse x transpose y. X transpose y means their dot product. So you multiply them element wise. 2 times 6, 12. 1 times 3 is 3. And then 3 times 9 is 27. You divide that by norm of each vector. So norm of x means 2 square plus 1 square plus 3 square under the square root. And norm of y means square root of 6 square plus 3 square plus 9 square. So we get 4 plus 1 plus 9, which is square root of 14. And here we get 36 plus 9 plus 81. So 81 and 90 and 36, 6, 12, 126. So this is square root of 126. So square root of 14 times square root of 126. So we get cosine inverse of 27 and 3 is 30, 40, 42. 42 divided by square root of 14 and square root of 126. So when you do cosine inverse, it will give you a degree. It will give you a degree. So you want to get a calculator in degree mode. Degree mode in calculator. So whatever calculator you have, you need to play with it so that you can find the inverse. You know how to apply the inverse function. I don't know how to use inverse function here. I don't see any inverse function. I see only the original function, cosine, secant, tangent. So I couldn't do this here, but in your calculator, it will have a cosine inverse. Another name for cosine inverse is called arc cos. So if you see the bottom for arc cos, then it means cosine inverse. Or you can see, let me see if it works. I didn't try it before, but oh no, it will not work. Sorry, my bad. So you need to know how to find cosine inverse in a calculator. So cosine inverse of, you need to know what is the inside. So let's see. 42 divided by, since denominator has 2 elements, so you need to put parentheses. So you get 14 square root times 126 square root, close it, and then we get 1. So this inside is 1. And from your pre-calculus, you should know that cosine inverse of 1 is 0 degree. So the angle between these two vectors is 0 degree. What does that mean? It means the two vectors you have, they are actually the same vector. And observe, we have 2, 1, 3 and 6, 3, 9. If you multiply this vector by 3, you get 6, 3, 9. So one vector is here, the other vector is 3 times longer. That's why the angle between them is 0. So these two vectors, they are not orthogonal. The angle between them is 0 degree. Sorry, If the angle between them is 0 degree, the angle, if orthogonal means they're perpendicular. So two lines are perpendicular if the angle between them is 90 degree. So if the angle between them is 90 degree, they are orthogonal. Or if their dot product is 0, then they are orthogonal. So in both cases, we get two orthogonal vectors. Means one vector is perpendicular to the other vector. Any question so far? Are you guys understanding what I'm talking about? Or you guys just listening me? Any compliment from anyone? Come on, guys. Only 5 of you are here. Tell me which part is not so good. You can unmute yourself.
Why is this
Okay.
chapter important? What are we doing here?
We are learning about the angle between two vectors, the projection of one vector onto another vector, and then closest point, the closest distance from a point to a line. These three things are important. If you have two vectors, you want to know what angle we have between them. Why do we care? We care because if the angle is 90 degree, they are orthogonal. And when they are orthogonal, we have a benefit. We can do extra things with them.
When the angle's 90 degrees, isn't that just the Pythagorean theorem then?
Yes, that means
A squared plus B squared equals C squared?
right. So you can find their distance easily from a square plus b square.
Okay. So that's
Plus
how
in linear
easy you are.
algebra, we can do many more things with
Okay.
orthogonal vectors.
Okay.
That's why we care.
But so we're also finding the distance between two vectors that are not 90 degrees?
Sometimes the degrees are not 90 degree. That means the two vectors we have, they don't have any relationship. For example,
Okay.
here, this vector and that vector, they don't
Yeah.
have any special relationship
Okay.
because they're not 90 degree.
Okay. Thank you.
So when they have a 90 degree, they are special. And we can do many things, many more things with the special vectors. That's why we care about orthogonality. Now, the second thing we care about in this section is projection. Projection means, let's say you have a vector here and you have another vector here. Now, let's say this is x vector and this is y vector. So if you lit a light here on the x vector, it will create some projection onto y. So we want to know how much of the y vector is a projection of the x vector. Projection of
Does the
x.
light being shined have an angle too?
Uh,
Or is it always like straight down?
I think straight down.
Okay.
I actually didn't think about that.
Okay. I'm confused.
Yeah,
Okay.
probably do it this way or maybe that way. They
Okay.
actually never mentioned it in the book,
Okay.
but it's a good
I'll look
question.
into it. I'll look into it. Thank you.
Uh, so if you lit a light, how much this x vector take up from the y vector? So if you're looking for how much, that's called a scalar projection. It's a number, how much scalar projection. And then you want to know, well, in the y vector, what is the projection vector? So definitely the entire vector is not the projection vector. Our projection vector is only from here to here. So what's the location of this projection vector? What is the name of this projection vector? Name means the location, means the number. What number we have for this projection vector? So that's the second thing. The scalar projection tells us how much we take from the y vector, and vector projection tells us what is the vector we have on y that is a projection of the x vector. So how do we find them? Again, we use formulas. So the scalar projection can be measured by the formula x transpose y divided by the norm of y. So the projection of x onto y is their dot product. So you multiply them, x and y, and you divide it by the norm of y. So you do that. This is one formula. Another formula says, all you have to do is look at the unit vector, and that unit vector will help you to find the projection vector. I actually don't quite understand the unit vector concept, so I always avoid that. So my favorite formula is this one because this is easier to remember. And for the vector projection, this is my favorite formula. So all these formulas are correct for projection vector. You just have to use one of them. The best one, I think, is the last one. So if you want to look for the vector, you do the scalar product and then you do a little bit more. So scalar product times the unit vector of the y. So scalar product is x transpose y over the norm of y. So you can see we have norm of y twice. So it's norm of y square. But what is norm of y? It's square root of each component square. So the square root and square cancel out, and you get their dot product, the dot product of the vector. That means you don't have to square root. Now, what's the difference? The norm of y is square root of the sum of each component square. It's the norm of y. But if you look for the dot product is same. It just doesn't have any square root concept. The norm has a square root in the formula, but the dot product of the vector doesn't have any square root. That's the difference between norm and y transpose y. So you get a number, and then you multiply the y vector by that number. And then you get a new vector, the vector that projects onto the y for x. So people call this new vector, the projection vector, as P. So P is the projection of the x vector onto the y vector. Now, if you compare the x vector with its projection vector, the distance from x and this projection vector is called x minus p. So you subtract p from x, whatever you get, that is x minus p. So what do you do? It looks difficult, but actually all you have to do is put together all these formulas and then you'll be fine. You have to know what each formula mean. So the distance, the
Wait,
vector you get,
does this formula return 2 points? Or
vector, the vector projection gives you a vector. The scalar projection gives you a number. So scalar means number and vector projection means it's a vector. We're going to get a column vector.
Okay.
So scalar projection means how much is the projection. And vector projection means what is the vector of that projection. So you're looking for two things. The length of the projection and what's the actual vector itself. So to find each one of them, you use different formulas. So all you have to do is put together your formulas and then you'll be fine. For
Okay.
example, let's say we have two vectors. One is 213 and the other vector is 639. We want to know what is the scalar projection of this first vector onto the second vector. So suppose the first vector is here, 213, suppose, and the second vector is here, 639. So you want to know when you project one vector onto another vector, how much it takes and what is the actual vector. What is this vector? This is what you want to find. So first we do scalar projection. The scalar projection has a formula alpha equals x transpose y divided by a y. Here, they didn't give us x and y, but this is x and this is y. Whatever you are projecting onto, that goes on the denominator. We are projecting v onto w, so this formula becomes b transpose w divided by the norm of w. The big one, whatever you're projecting onto, it always goes in the denominator. Now b transpose w, it means you're multiplying them element wise. So we got 2 times 6, 12, 3 times 1, 3, and 3 times 9, 27. Divided by norm of w. Norm of w means each element square. So square root of 6 squared, 3 squared, and 9 squared. So on the top we get 44. On the bottom we get square root of 126. So this is the scalar projection of V onto W. Means this length, this much length is whatever number that is. Let's see what number is that. 44 divided by 126 square root 3.92. Also, it's not 44. It's 42. 42 divided by 126 square root 11.2. 126, right? 36 plus 9 plus 81. What I'm doing? 36 plus 9 plus 81. Yep, 126. So this is 11.2. Means this much is 11.2 inches or whatever that is. 11.2 inches. Now we want to know what is this vector from 0, 0 to here. What is this vector? What's the location of this vector? So we go to vector projection. Vector projection. Vector projection we write using P. P means vector projection, which is also written as projection of V onto W. So you're projecting V vector onto the W vector. So its formula is B transpose W, and then you do W transpose W, and then you multiply the W vector with that. So you're going to get a vector onto W, okay? That's why you have to use the W vector. What do we get on the W vector? Which vector do we get on the W vector? That is a projection of the V vector. So this is our V vector. When you project, what vector do we get on the W vector? So B transpose W is this one, which is 42. Now W transpose W is 126. So remember, W transpose W means you're multiplying W itself. 639, 639. So 6 times 6, 36. 3 times 3, 9. And 9 times 9, 81. So this is 126. And then our W vector is 6, 3, 9. When you reduce, 42 goes to 126 3 times. So it's 1/3 of 639, which is 6/3, 3/3, 9/3. So we get 2, 1, 3 vector. It means the vector you have here, it's 2, 1, 3. So from 0, 0 to here, the location is 2, 1, 3. So you're going to X 2 units, Y 1 unit, and Z 3 units. And if you observe, these two actually the same graph. So in our graph, same vector. So this is your 2, 1, 3, suppose. And this is your 6, 3, 9. So when you project these 2, 1, 3 into 6, 3, 9, you get the small vector, the smaller vector as your projection. Because they are the same vector. So their projection should be the length for the smaller one. So when you try to see the projection of the smaller length on the bigger vector, it gives you the smaller vector back. This is what it means. Okay. So bottom line, you have to remember these formulas and the definition for each one. For example, what is B transpose W means? What is W transpose W means? What is norm mean? Any question? If you're confused, please let me know. Okay. So another example. We are going to do the same thing. We're going to see the vector projection of x onto y. So let me actually draw this one. It will be easier for you to understand. 3, 4. 1, 2, 3. 1, 2, 3, 4. So this is the vector 3, 4. And we have another vector 1, 0. So 1, 0 is here. So this is our second vector. Now it says find the vector projection of x onto y. Means when you put light here, how much of the x vector goes into the y vector? So obviously the projection goes here. So how much is this? So from this picture, it looks like it goes to 1, 2, 3. It looks like, okay? So let's see algebraically how do you solve it? How do you find this vector? So what is this vector? This is our goal. What's the location of this vector? So we are finding P, which is projection of the x vector onto the y vector. So the formula, x transpose y divided by y transpose y. So we are projecting onto the y, so it has to go on the bottom. Also, we are going to project onto the y vector. So we are going to multiply by the y vector. So x transpose y means you're multiplying them column-wise. So you do 3 times 1, 3, plus 4 times 0, 0. And then y transpose means you're squaring each element. 1 square plus 0 square. And then our y vector is 1, 0. So this is the projection vector y, projection of x vector onto y. So 3 plus 0 is 3, 1 plus 0 is 1. So when you multiply, we get 3, 0. Ta-da! We get the same thing, what we inspected. Now, they want us to do something extra. They want us to know this P, the projection vector, and x minus P are the orthogonal. So we found P is 3, 0. So x minus P is 3, 4 minus 3, 0. 3 minus 3 is 0. 4 minus 0 is 4. So you want to see this P and x minus P, they are orthogonal or not. So x minus P is actually this one. The vector length from here to here is called x minus P. So if this is the P vector here, and this one is x minus P vector, they want us to know whether they are orthogonal or not. Means, are they connecting within 90 degrees? So we do P times x minus P. So 3, 0 times 0, 4. Oh, we have to do transpose, otherwise you cannot multiply. So 3, 0, 0, 4. 0 times 0 is 0. 0 times 4 is 0. So yep, that product is 0. Since that product is 0, that means P is perpendicular to x minus P, or P is orthogonal to x minus P. Means yep, their relationship is a 90 degree. So the vector projection and no. So basically they are saying that any vector project onto another vector with a 90 degree angle. This is what it means. The angle of the light, I don't know, but the projection is always 90 degree. Okay,
Professor, I have a question.
go ahead.
How many questions would this be on the final exam? Like from chapter
One
5
question
exactly?
is this. Find
One
the
question?
vector. So one question for angle between the two vectors. One
Okay.
question for scalar. One question is for vector. And one question is for orthogonality.
Okay. And you have a recommended homework for this?
Yes.
Perfect. Okay.
But we have one more concept. And then you're going to, I'm going to show you the questions. Plus, I'm going to post a 1-page review on chapter 4, 5, 6, 4, 5, 6. So you'll see which question will come in the final exam. So in the final exam, 1/3 will come from chapter 4, 5, 6, or probably 2/3. 1/3 or 2/3 will come from 4, 5, 6. 1/3 or the rest 2/3 will come from exam 1 and exam 2. Okay. So for the final exam, our review is review 1, review 2, basically exam 1 and exam 2, and the new materials we learn in chapter 4, 5, 6. Now the last concept in this chapter is finding the closest point on a line. So let's say we have a point here and we have a line here. We want to know what is the shortest distance from this point to this line. Like, is it the shortest distance, or is it, or is it, or is it, or is it? Which one is the shortest distance from this point to this line? So what we do is, in order to find that, we are going to use the projection. So out of this point, we create a vector. Let's call this vector V. So we make a vector from the point. And then, since this is the line, so it's going on forever. So we take a vector from this line. Okay. So we take any point on the line, and let's say this is the vector W. So we make a vector with the point. We make a vector on the line by picking a point on the line, and then we project light onto the vector. So this vector will project with a 90-degree angle. So whatever we get here on this line from the projection, that would be the shortest distance from the point on the line. So we are going to find this point. This point will be the shortest distance. That's the criteria. Definitely we can solve it using calculus. We don't need matrix algebra. But matrix algebra makes it a little easier if you understand. So for example, we have a line y equals 1/3 of x. And they gave us a point 1/4. So this is the point 1/4, and this is the line 1/3 of x. So our step 1 is create a vector from 0, 0 to 1/4, and let's call it V. Then pick any point on the line and make another vector. Let's call it W. Then shine the line on the V and observe its projection. What's the projection vector we get here? Projection vector. This projection vector gonna give us the location of the shortest distance from this point to this line. So step 1, find the vector V. Vector V is basically you are writing this as a vector form instead of a point form. So let's make vector V from the point 1/4. And now let's make a W vector on the line. How do you find it? You just pick any X value and Y value on this line. So our Y is 1/3 of X. Now let's say our X is 6. Okay. So if X is 6, Then our y is 1/3 of 6, which is 2. So we picked a point here, and we got the vector, which is 6, 2. Now we are going to project V onto W, and then you're going to get the results. So you're going to get a vector. That vector is the point we are looking for. Now this projection is V transpose W, and then we do W transpose W, and we are going to project that on the W vector. So whatever you're projecting onto, that has to be the vector here, and that also has to be the denominator. So our V vector is 1/4. So 1/4, and W vector is 6, 2. So their transpose 1 times 6, not transpose, sorry, that product is 1 times 6 is 6, plus 4 times 2 is 8, divided by the W transpose W. W transpose W means 6 square plus 2 square. You're just adding their squares. And then the result, whatever you get, you're projecting onto the W vector. So this is our W vector. So what do you get? 6 plus 8, 14. 6 square is 36. 2 square is 4. So we get 14 over 40, 6, 2. Now let's see, what do we get? This is reducible. So we can reduce 7 over 20, 6, 2, right? 7, 2, and 22. Yeah. So that's gonna give us the point. 7 divided by 20 times 6 is 2.1, and 7 divided by 20 times 2 is 0.7. So the point we are looking for, which is the closest point here, is 2.1 and 0.7. And this is the closest point, closest distance from the point 1,4. Any question? And this is our last topic. So from this section, there will be 5 concepts. 1, 2, 3, 4. The 5th one is closest point. Wednesday class also will go online because of my voice. I'm so sorry. But next week, Monday, definitely, inshallah, our class will be in person. And Wednesday, we are going to do review. Okay. Any question? Any question from any of you? Andy, Jackson, Mehrab?
Hello?
You said no.
Is class
No,
over?
hello.
Any question from you?
Oh, no. I understood today pretty well. I
Great.
just I just need to like
Oh,
practice some more.
here. These are the
These
practice
are the homework
questions.
exercises.
Mm-hmm.
Okay.
So
I'll take a
1D,
screenshot.
2D, 3D, and question 5. And this is a screenshot of all these questions. So try them, and at the back of the book, they have a solution. Or if you put them on Google, you'll see the solution. So you can match your work with them.
For some
Plus,
reason, I'll send you a screenshot of my textbook later, but like I don't have letters. Like it's like
I
we
know because the version is different. The version you have is the older version, I think. And
oh,
the other way around, probably. I don't like this is the book I received from the department.
is there a way I could get that version?
No, it's only ebook. It's not
Okay.
PDF version. It doesn't have any PDF version. So it's the same
Okay.
question, same everything, but
Mhm.
the ebook is different than the PDF.
So my version, I will be able to practice.
They are the same question.
Perfect. Okay.
So D means is question number 4. D means 4. 4. So you have every question 1 and then 1, 2, 3, 4. See here I have A, B, C, D, but in the PDF it says 1, 2, 3, 4. They're the same
Okay.
question.
I saw some people leave early. Is the lecture concluded?
Yeah, that's all for today.
Okay. All right.
So meet you again Wednesday
Okay.
online.
Wednesday online.
Mhm. And if you need any help, just send me an email to set up a Zoom meeting, and then I'll help you one-to-one.
Do you know the schedule for the Dosiani Center?
You can search online actually.
All right, perfect.
They
All
sent us
right.
an email, but I disregarded that email. But you can search it online, and they are open most of the time because of the final. So you
Okay.
can go there anytime.
And what happens if you're not able to make it on the 17th?
Then you'll decide. So our actual exam is 22nd,
Mm-hmm.
but 22nd is very far
It
from
is.
now. So definitely you're going to forget all the materials you learn. Plus, I have to grade all the exams in a hurry so that I can post them to CUNY first and register office, which I don't want to do. That's why if most of you can take it on 17th, that would be great for me because I have more time to grade. So if you cannot make it, no problem. My plan was to invite you to Baruch at your convenience time and then take it here.
I think I will be able to make it on the 17th. And I just have to figure out like how I'm gonna balance out studying because I'm also taking a lot of other classes, but I think I will be able to make it.
Do you have any other exam on 17th?
Not exactly, but I have 2 exams on the 16th and
Okay.
then another 2 exams on the 18th, but I'll figure it out.
Mhm. So if you cannot make it on 17th, can you make it on 18th?
18th?
Yeah.
No,
I mean, no,
17th would work.
18 is
17th.
actually a good idea
Yeah.
because 18 I have my own final. 19 Friday.
I'm sure the 17th will work. I'll figure
Okay.
it out.
So yeah, what I will suggest is that since we still have more than 7 days, so for now, do these questions 4, 5, 6,
Mhm.
7. Chapter 4, 5, 6, 7.
6 and
So
7?
yeah, 4, 5, 6, and
Okay.
7. I'm going to post a review sheet tonight.
Okay.
So try them. And
All right.
then if you're okay with that, then move on to the very first section, which you're going to do Wednesday.
I was planning on like you were going to post a review sheet. My study plan was to like do all 3 review sheets